Have you ever looked around your room and realized how strange it is that you can see everything, but not the thing that actually lets you see? You notice the posters on your wall, your desk, your water bottle, even the dust floating around when sunlight shines through your window. But the light itself, the actual thing lighting up your whole world, never shows up. It feels like the one thing we rely on most is hiding in plain sight. That's the starting point of this idea. Light might actually be invisible. First, what does it mean to see something? In physics, seeing something means that light reflects or gets emitted by an object and certain wavelengths of that light reach your eyes. They trigger your photoreceptors and then your brain builds an image out of that signal. Pretty simple. But if you think about it for a moment, we don't actually see light itself. We only see what light does to the things it hits. A big reason for that is that light is massless. Since photons have no mass, they don't take up space the way normal objects do. Things with mass can be seen because they block or reflect light and form clear shapes. Light doesn't block anything, not even other light. It passes straight through itself without leaving an outline or a surface for your eyes to detect. That already makes it very different from everything we normally see. Another thing is that light becomes visible when it hits matter. A beam of light in empty space is completely invisible. It only appears when it runs into dust, fog, or water droplets, because those particles scatter the light into your eyes. When you see a sunbeam in your room, it's not the light you're looking at. You're looking at the dust the light has revealed. Without something for light to bounce off, there's nothing for your eyes to collect. And because photons don't block each other or act like physical obstacles, they can't create shadows. Shadows work because an object gets in the way of light. Light never gets in its own way. It can't cast a shadow on itself or stop another beam. If light behaved like matter, you'd be able to see silhouettes of bright rays, but you never do. This is the same concept with fire. You never see the shadow of fire, and you can actually try this out for yourself. Light always reveals other things, never itself. This also helps explain why space looks dark. Space isn't empty of light, it's full of photons traveling across the universe, but most of that light never hits anything on its way to your eyes, so it remains invisible. Even the sun, which floods the inner solar system with light, doesn't make space itself bright. Its light only becomes visible when it hits planets, asteroids, dust, or gas. The vast stretches of empty space between objects stay dark. Darkness in space isn't the absence of light, it's the absence of something for light to reveal. Every object and living thing around you has mass. In physics, an object has mass if it resists a force. That resistance is inertia. You can see this in Newton's second law, where force equals mass times acceleration. One of the least massive things in the universe is the electron, at 9.11 times 10 to the negative 31 kilograms. And one of the most massive things around us is the sun, at 1.989 times 10 to the 30 kilograms. Now that we have a sense of what mass means, let's talk about Einstein's famous equation, E equals mc squared. In this equation, E is energy, m is mass, and c is the speed of light. But there's a more complete version of this equation. It goes E squared is equal to m naught c squared all squared plus pc all squared. Here, m naught is the rest mass of an object, the mass it has when it isn't moving. P is momentum, which is a measure of how much motion an object has and how hard it is to stop it. Photons have no rest mass because photons never stop moving. They always travel at the speed of light. If light had even the tiniest mass, it wouldn't be able to reach that speed in the first place. Einstein also showed that as objects move faster, their mass effectively increases. You can imagine throwing a ball faster and faster. As it gets closer to the speed of light, it feels heavier, until it would take infinite energy to speed it up any further. That wall stops everything with mass. Photons are the exception because they start at that speed and they never slow down. This ties back to why light is invisible. Since photons have no rest mass, they can't block or resist anything the way normal objects can. They don't collide in a way that creates visible surfaces, shadows, or shapes. They fly through space unnoticed unless they hit something with mass that redirects them into your eyes. Light itself does not show up. It only makes the rest of the world show up. What we see is never light moving through space. What we see is what light touches. And that's why, even though the universe is full of light, most of space appears dark. Even the sun, despite filling our solar system with light, doesn't make empty space glow. The light is invisible until it interacts with something to reveal it.